Welcome. In this video, we're going to begin talking about quadratic equations and different solving strategies for dealing with them. First thing we want to know or recognize is understanding what a quadratic equation is. So a quadratic equation in standard form is written as ax squared plus bx plus c equal to 0. So standard form, we've got the squared x to the first, and then no x to the 0th. So we have it written in descending order. A, B, and C. A, B, and C represent real numbers. And the only restriction is that A is not allowed to equal 0. Well, why is A not allowed to equal 0? If I let A equal 0, 0 times x squared would be 0, and we would not have a quadratic equation. We would have something that is linear. Okay, so in order for us to deal with a quadratic equation, we need to know what it looks like, and what it looks like is, being defined as ax squared plus bx plus c. So in descending order, squared term, linear term, constant term equal to 0. Now, quadratic equations are going to have that x squared, and what you're going to notice is that a quadratic equation always has two solutions. So we have three methods in this class we're going to look at for solving quadratic equations. The first method, which always works, is the quadratic formula. The second method, which works occasionally, would be to factor and then use our zero product principle to solve each factor equal to 0. So factoring only works sometimes, but the quadratic formula always works. And then we have the square root principle. And the square root principle works when we are missing that b term, when b is equal to 0. If b is equal to 0, there is no linear or b term, and we would just have ax squared plus c equal to 0. So if the linear term, the center term, is missing, we can use the square root principle, or we can complete the square to use the square root principle. So three methods. Quadratic formula always works. You need to know it. You will have to use it. Factoring works sometimes, but not always. And then the square root principle is helpful when we have specific formats. So what we're going to talk about are what these principles are, and then we'll look into using them in the lecture videos that follow this. So the first and most important formula is going to be the quadratic formula. The quadratic formula tells us the solutions, the two solutions, which we will always have for any quadratic equation. So if we are given a quadratic equation in standard form, and we can note what my A, my B, and my C value are, then the solutions can always be found by using this formula. And that's going to be x equals negative b, so negate the b, plus or minus the square root of this quantity, which is b squared minus 4 times a times c, all of which is divided by 2a. So this is our quadratic formula. And yes, you need to commit this to memory, and you are going to be using it through all of your future math classes. All right, so we know how to solve anything. If it's in this quadratic form, we can determine two solutions. All right, next up we have the zero product principle. And the zero product principle is useful for when we are dealing with quadratic equations that are factorable. So if we are able to factor it, then we are going to use the zero product principle. And what this says is if we have some product, in this case I'll say A times B, and if that product, A times B, is equal to 0, what can we say? So if I'm multiplying two numbers and those two numbers are equal to 0, that product, then what must one of those numbers be? And there's only one way to make 0 via multiplication, and that would be either A is 0 or B is 0. Okay, so if we have some quadratic equation equal to 0 and we've been able to factor it, then we can take either the first or the second factor, A equals 0, B equals 0, my first and second factors, and I would set them equal to 0 to solve. Just a notation note here, when we draw this double barred arrow like this reads as the word then. So it's kind of like an if-then statement. If we have this, then we can assume that. All right, and then our third principle, our third method that we used would be the square root principle. And the square root principle says if we are solving something and we use a square root, we have to put in a plus or minus. Rather, if we say x squared equals k, so k can represent a constant. It could also represent an expression. So if we have a squared variable equal to some constant or some expression, well, what we can do is I'm going to use a square root. That would be the inverse operation. That would be x equals plus or minus the square root of whatever k was. So the main idea here is I started with a square and I turned that into a square root. So essentially I'm using a square root to solve. And if you ever use a square root to solve, you must write plus or minus in front of it. And the logic for this should make some good sense to us. If I said x squared equals 9, well, what number or numbers squared equals 9? So most of you are saying, well, 3 squared equals 9, but also negative 3. Negative 3 squared is equal to 9. So both of these values equal 9. And we would need to state that both of these values would work. So if I was solving this and I used a square root, I would take the square root of both sides. It would cancel on the left. And on the right, I would have plus or minus the square root of 9, which would, again, as we've just said, tell me that x equals positive or negative 3, because there are two numbers that I could square to plug into that. So if you're solving a problem and you are using a square root to solve, you must include the plus or minus. So in this video, we talked about our three methods: the square root principle, the zero product principle we use when we have something that is factorable, and then also the quadratic formula. So each of these three principles, and then in the videos that come after this, we're going to use those principles or methods to solve different types of quadratic equations. As always, please feel free to email me with any questions or concerns.